of nodes. But what is happening in ERM model? Yeah, in ERM model, what happened? That is that they are fixed. But if the nodes are fixed, we can't generate the randomness. So we need to find a way to find the randomness. So that is there where we'll be getting the process known as random rewiring. So random rewiring is a process which can create long distance connections and add randomness to the generated network. So hope you get that, you get the point. So random rewiring, it is a process which can create long distance connections and add randomness to the generated generated network. What is the most use of, for example, if you consider it in a Facebook, if you send one request to your friend and your friend of friend will be sending you a request, that is what the random rewiring is. So we need to create a lots of randomness to get the connections or to increase the network. So for each network with probability p will be, so we have to check that every node should not be having a self loop, as because we will be calculating the degree distribution, right? So the in degree distribution of cluster coefficient there will be no self loops. If there are self loops, then we will not following the power law. Okay, so we should check that the distribution or the graph networks should not contain the self loops and the duplicate links. So for each network with probability p, while avoiding self loops and link duplication. So we need to check this is how we will be generating network in WSM. So let us try to jot down the limitations. So what are the limitations of this? So their degree distribution is realistic, because if it has self loops, we can't find the power law because it doesn't follow the power law. So if there are fixed nodes, if they are fixed nodes, then we really can't generate the randomness. So these are the two limitations of WSM. So limitations, what are these limitations? It has unrealistic degree distribution, which doesn't follow power law. We have to check each and every network that we should definitely follow the power law. Power law is nothing but we have to increase network. In case if it is if it why we should follow the power law, because if a node A tries to create the network within itself, there is nothing much it can grow to the other side, right? So that is what the one of the main law, that is what the one of the limitations here. And second limitation is it has fixed nodes, right? So what will happen in real world network? In real world network we will be generating it continuously. For example, if we take Facebook is one of the best example. Facebook, Twitter, or the consider internet, we'll be having millions and millions of nodes, right? So we have to grow that nodes as it is without fixing of nodes. If there are 2 points, so there is no chance of forming a cluster. So it is fixed number of nodes, unlike real world network of nodes. So fixed numbers of nodes are present, unlike real world network nodes. What will be doing? Nodes will be grow continuously. Continuously grow. This is the two limitations of WSM model. So let us try to make of the third model, that is Barabasi-Albert model. In Barabasi-Albert model, what we'll be doing is we'll be solving these two problems, that is unrealistic degree distribution as well as the fixed number of nodes. We'll be solving it here by the using the preferential model, or we'll be seeing it. So we'll be describing the randomness also. We will be saying that you can grow as your progress. That is what Barabasi-Albert model speaks about. So let me write Barabasi-Albert model. So what is Albert model? Been before in ERM as well as WSM model, what happens? There are two limitations, that is unrealistic degree distribution and fixed number of nodes. But in Barabasi random model, they have characterized and described the continuous growth. That is, real world construction is the product of the steady growth process. That is, if you want to generate a 3, and it will be 3 will be generating 3 and 3 will be generating 3 and so on, like this. That is like Stalin movie. So it will be generating so on continuously as a product of a steady growth process. So let me write that. So they have characterized and described a continuous growth that is nothing but the real world network construction is the product of steady growth. Real world network construction is the product of the steady growth process. If there is a stability in the network, then what will happen? The entire thing which will be easier for us to get our network to grow. So now node in most real network prefers to link to the most connected node. That is nothing but the preferential model. So if I send a request to my friend, and what will happen? He will be sending the request to one of my friends, and one of my friend will be sending request to each one of a friend. There, what is happening? We'll be giving the preference to the nodes which you feel that it might be important in some other way. So this might be also one important point, right? Now, node in most real network prefer to link to the more connected nodes. So the best example for this Barabasi-Albert model is LinkedIn. So in LinkedIn, as many followers you have, you will be growing your network like that. In real world network also, LinkedIn is the best way to get internships or job offers, anything. So I kindly recommend students to have a LinkedIn account. So this is nothing but the preferential attachment model. We'll be discussing in next class. So preferential attachment model. This is also known as preferential attachment model. That is, we'll be giving. So in exam, don't write Barabasi-Albert model is also known as the preferential Albert model. So don't write like that. Don't repeat any point like that. Just it is an what will be say, this replica of Barabasi-Albert model, or just don't make it just a preferential attachment network generation. So give it a name as network generation. Preferential attachment network generation. So that is what all about Barabasi-Albert model. So we will be generating our real world construction with a steady growth process. That is the most degree or the most important node will be getting the huge connections. Example like LinkedIn. So what we have discussed so far. So we have discussed the small world model in small world network model. We have 3 models, that is Eddowes-Penny model, Watts-Stuart's model, Barabasi-Albert model. What does Aldous Rennie model says about Aldous Rennie model is nothing but the random graph model because it generates the graph randomly. It depends on the probability distribution P. So there are two variants, that is g of n comma p as well as g of n comma n. G of n comma p is nothing but the binomial distribution. G of n comma a is nothing but the uniform distribution. So how does the network generates in ERM? So how does a network generates? Here will be generated and generated network with n nodes, where each possible edge in the network is generally independent and identical distributed with P. So that is what we are already speaking about. So what is this limitation of ERM? Limit degree distribution is different because we are generating it randomly, and the cluster coefficient is also different. If you want to make that node stronger, we'll be giving the more edges to that node only before by not considering the other node. So real world networks are not generated randomly. Real world networks are generated randomly, but what is happening in ERM? ERM can't generate because it has fixed number of points. So what's the strategy model deals with the coefficient factor, and it will be having the fixed number of nodes itself. So what strategy is to get the highest coefficient. So he will be using a process called random rewiring process, where he will be generating the randomness to the network. So what are the limitations of the WSM? So it has unrestricted degree distribution because it didn't focus on degree distribution, but it has focused more on the cluster coefficient, because it cluster coefficient, it has fixed number of nodes unlike the real world networks. So it doesn't doesn't make the network continuously grow. In Albert Barbasi model, he has rectified these two limitations, that is unrealistic degree distribution as well as a fixed number of nodes. He has characterized and described the continuous growth formula, but continuous growth formula, that is real world network construction, is the product of the steady growth process. So we'll be discussing only theory here. There is no problem solving. We'll be, if that is very huge, so I didn't take the problem solving here. So no new node in most relevant preferred to the link to the more connected nodes, that is nothing but the preferential attachment network generation model. So what will happen if for example, if this is the honeycomb, for example this is the jaggery, what will happen? All the ants will come and eat it, right? This is what it is. This is one node. That jaggery is one node. This ant think that ant is the another node or the customer request, because customer request is tried to send to the jaggery or the node. That is what it is. Barbasi model, the best example is the LinkedIn. So that's all for today.